All right, here we go. We're going to start with a 32 Newton crate sitting on a floor. It's pulled to the right with a force of 82 newtons at 23 degrees above the horizontal line. The force due to friction is 24 newtons. Find the magnitude and direction of the net force. Take a second, stop the video, and draw this out. Hopefully you've got it drawn out. So here's what we're going to do. We're going to sit there and bring this up. So a 32 Newton crate sitting on a floor, 82 newtons. So let's first do this easy part. A crate sitting on the floor. Cool. There it is. In this case, it's a 32 Newton crate. F of G, 32 newtons. So there's the newtons. The crate gives us a little bit more information. It's pulled with a force. Switching. It's pulled with a force of 82 newtons at a 23-degree angle. And then friction is 24 newtons. So find the magnitude and net force. Yes? Okay, normally we would say start with F of G. So F of G, well, that's 32 newtons. Excellent. 32 newtons. We're going to do one more thing because we know force of gravity is equal to mass times the acceleration due to gravity. So that's 32. We don't know our mass. We know our acceleration due to gravity is 9.81. Grab the calculator. 32 divided by 9.81. We have a mass of 3.262 kilograms. Fairly light crate. Yes? So we've got the first part. So the next thing I'd say is, well, let's find your force due to friction. There it is. Force due to friction, 24 newtons. Okay? Well, now we have F of N, I would go to next, but we have this funny angle. So the force applied. So the force applied in the X, force applied in the Y. I will tell you, take a second, pause the video, calculate force applied X, force applied Y. So force applied X, force applied Y. Force applied X in this case, we're still dealing with this line, so it's 82 newtons times a cosine of 23. Force applied Y is 82 sine of 23. About messed that up because I sat there and looked at this one. These two should never match, meaning that should be cosine, that should be sine, or cosine and sine. If they're both the same thing, well, you made a mistake. So 82 times the cosine of 23 and 82 sine of 23. And how nice, someone switched my calculator to mode, to degrees. So 82 times the cosine of 23, that's 75. And 82 sine of 23, that's 32. So 32 newtons and 75 newtons. That should make sense. I'm going to scoot this over a little bit so we can continue on because we have to find our F of N. Well, remember what we said about F of N? F of N, actually here, to simplify, going up equals going down. The only force that's going up, normally is f of g and f of n. But we've got this funny thing over here. So we've got force being applied in the y direction at 32 newtons. So we have to include it. Force applied in the y. We said that was 32 newtons. So 32 plus our f of n we do not know equals our f of g, which was 32. Well, that's kind of convenient. So in this case, our f of n, our calculation for f of n equals 0. And you're like, wait a minute, Mr. Maybe that doesn't make sense. It does if you think about the problem. I am lifting the box up just as much as gravity is pulling it down. So in reality, there is no motion up or down. In fact, the orange ground here is not doing any force up on that box. I'm lifting it. Very inefficient, but that's the way it goes. Yes? So we found our f of n, we found all of our forces. We need to summarize this and actually come back to the original question. Sum of the forces in the x direction. Speeding you up minus slowing you down. Well, are we sliding down a hill in this question? No. The only thing that's speeding us up in this case is the force applied in the x. What's slowing us down? Force due to friction. So in this case, force applied in the x, we said was 75 newtons minus our f of f, which was given to us in the problem, was 24 newtons. 75 minus 24, hopefully if my brain works correctly, some days it does, is 51 newtons. The sum of the forces in the x direction is 51 newtons. In this case, if we look back at our diagram, 51 newtons, the force this way is 75. The force that way is 24. Should make sense. It is 51 newtons to the right. That answers the question. This encompasses all of section A, B, C, and D. Take a second, do the work, see if you can do that. And I'm going to host one more. Our next question will be here in blue. Take a second, pause it, try it on your own.